No, so you look at some of the singletons, right? The twins talk to each other. So literally, they don't really need to do much.
I'm trying to screen share.
They've already bonded with each other. Second thing is they never not even when they soil their back. It's
Okay. Welcome back to the Mars Rover Teacher Training Workshop. We will actually start in 4 minutes. When I told them the break would be over.
they ride them around at 6 o'clock. Just bring them down here. And she just put them in. So when she wrote it down and I started thinking about it, I was like, oh, I was like, did you just put them in the, she's like, yeah, so it's a treat for them? Apparently they love to ride on the buggy. So when she just put them in there, and here I am, Daddy, taking them out of the buggy, they get their buggy ride. They're mad. I know. They were both mad at me. And then if we were driving, they calmed down. I was like, I'll let you ride this. But they didn't have a bouncy thing where they open their mouth and they just enjoy it. Right? It just goes up and down and turns, but it's like it's almost like going to an amusement park. That's their favorite. They crawl over there and start trying. That's what they're not even one that. It's the little things that only one is silent there and real estate. So someone was telling us a movement of all they can really care about is bars. They don't even focus on the animal, it's just going to be the bars. You never know. It's going on. You never know. It's my boys have been fascinated with the word boss. But you do. Like golf? Oh, twin legs. They always talk to each other. They seem to be able to because they understand each other. That is amazing. I'm just like, serious? What are you? Oh, first cousin. What's her first cousin? What is her name? Tisha. Miss Tisha. I don't have a picture of her. I worked for a firm. I ran a branch there, and then I got recruited by the depot. So I branched right there. So I went downtown, and I'm very familiar with worked with GE. So you're from No. Oh.
We may actually have to turn the lights down. There we go. Okay. Now this tool is Worldwide Telescope Mars. And it was written to provide professionals with swift and basically seamless access to the world's entire collection of astronomical images. And they have since discovered that, well, it's actually, they did a really good job of writing the tool as a tool. And so what we're looking at actually is a combination of digital array and images. You can look at a planet, a panorama, or the solar system. Let's see what happens if we click solar system. No, I don't think I clicked solar system. Okay, so this just gives you various choices of image, and you click on these pictures and it shows you where they are in the solar system, or on the planet. And there are 4,516 pictures of Mars currently in their database. And you can get more if you want to. Right now, we're looking at Mars named features. I could switch to Mars Top 10, and so we could look at, or we can go up a level, back to this. These are collections that that they have put together, or that you can put together for yourself. But they also have guided tours. Tour home. So they have a bunch of Mars tours that you can use. This is, again, a tool that you actually might want to, let me click on that.
Welcome to Mars. At least, welcome to Mars as viewed through a worldwide telescope. Follow this tour for a snappy overview of our Mars.
Oh my. It did not like that. It decided to crash. Well,
What is Microsoft?
what? It is Microsoft, yes. And it also, it gave me a debug option. Well, I won't waste your time. That shouldn't have happened. But I suspect it has something to do with this configuration. The fact that I'm trying to do it onto the screen, and I've got another computer hanging off mine in parasite mode, and I may try this again at home, and maybe we'll try it again next week and see if it works. It's supposed to work, but it works fine on my desk. Advice. That's the frustrating part. It works fine on my desk. So I don't really know quite what to tell you. Okay. Well, we have another activity. I actually don't have the handout sheet, but in the handout sheet, there is some pages labeled GSI journals, and this is an activity called Setting the Scene. And it's an activity, Laura's left. I'm going to ask her to find it. I'll find it. So find them and spend a few minutes examining the journals, and there's a KWL chart you're supposed to fill in, and this activity is not actually in the Mars Rover curriculum, but it's a related activity you could use along with it. It's from the Lunar and Planetary Institute webpage. Let me see if I can find where it is. In this massive collection of paper.
Is it this one you're looking for?
Yes.
Okay, it's like 10 pages from the front of this page.
In the second part, okay.
About 10 pages from this document. What does it look like? Oh, okay.
So what you have here is called the Geological Scene Investigator Journal. And you want to look through it and spot so we're actually doing the activity called scratching the surface, which is the very first part of the journal. And the activity is described some pages later. So your first step is on the screen. Fill in your journal and then you're going to team up. Well, we've got 3 groups. And so you'll get to pick one group, at least one group should investigate the Earth, the other 2 can investigate Mars. And then you're going to provide the teams separately when you're doing this in your classroom with either the Earth images, which are, there are 4, 5, 6, 7, there's roughly quite a lot. There are 14 images from Earth and a bunch of images from Mars. And so it's all mostly in here. It's most of this handout. So team up, divide yourselves, revert to childhood. Step 1, revert to childhood. Second, investigate, decide if your group is investigating Earth or Mars. Now you're already in smaller groups of 3 or 4. Yes, I don't want to be a grown-up anymore, children. Have any of you seen that poster? Yes, I have abandoned adulthood. Anyone who wants me can find me in the living room inside my sofa fort. Amazing the universality of some concepts. You say sofa fort and you know immediately what I said. The one that's strange with, though, my wife fancies a organic, unsweetened, crunchy peanut butter. And my daughter said, this has the consistency of driveway cleaner. Now, I've never actually seen that product, driveway cleaner. But the phrase immediately conveys virtually the same thing to everybody. Okay. So now that you've all got your images out, you may examine the images and organize them by the types of features they observe. How many different features are there? Characterize the features. What are their shapes? Are they above ground level, below? Can you spot any features? And, now, you would not necessarily show the students this slide, but invite them to name the features with whatever language comes to their mind if they don't have the word craters or river delta or alluvial fan. We don't necessarily expect them to have completed high school earth science in order to do this, so they can be, or you can be, as creative as you want. So let's see. And there is a way to tell craters from volcanoes by observing the shadows. And you can take a soup bowl or a cup and use a flashlight. I'm actually equipped for this. I'm not going to use a soup bowl, I'm going to use a cup. But you can see how the shadow falls on a mountain, which could well be the circular feature on the top, could be the caldera, although you'll never see one this steep, because that cup is much steeper than the natural angle of repose for rock on the earth, which is about 37 degrees. An impact crater, well, again, you won't see one that looks like that, but you can see the shadow inside a bowl is better, so maybe I'll use this bowl-like feature. You can see the light and the shadows inside are very different than for a volcano. So that's a way that the students can tell them apart. So I'm going to give you about 10 minutes to examine your images. So there are some questions. For one type of feature, how are the different? So record your observations in the GSI journal, record the features you found, and ask some of the questions. It's actually very hard to come up with inquiry-based learning about another planet. You don't have a whole lot of access to other planets. Unless you have 8th graders like my son's classmates. So 10 minutes to work on these images.
If you look at it, if there was a seven,
It's work. Yeah. Yeah. It's a work on Mars.
like right underneath, you can get into,
I think it's nice. We're gonna send the rovers our
Now, this activity, as I said, is not in our curriculum, but you can get it if you go to the Lunar and Planetary Institute website. And I gave that URL a while back. So 10 minutes to look at the pictures.
for some reason they found that.
They know great.
I don't know.
Cartoon or parents.
Probably a cartoon.
They don't just come up with words because they heard.
Even if it comes out of craters, stars, yeah.
Now, for adults, examining these images may be pretty straightforward because you've seen them a lot, but you need, as you should be thinking about, how do I teach these images in my classroom?
Sixth graders learn what I teach them. Part of the oh.
This one I remember more.
Oh, you don't have before? Okay. I'm so fascinated with stuff like.
Yeah, that's what I said.
That's interesting because is that a crater or is that the? Oh, okay. Well, we can't see because we don't have enough. But you know, it's definitely.
Yes.
So we know it's not a mountain.
No,
It's like a mountain. It's not a mountain. It's a hole.
yes.
The question is it greater?
Because of volcano, if you look at it.
See, that's just one. Remember those pictures? Yeah, see, that's it. And but if you think about it,
Yeah.
does it look like this? Does it look like
This is right here. This
Okay, but is that a crater or like?
Now this one is like a because I see I see a whole.
Right.
Might not be the same one, but it's
the same
like a bunch of them. So I guess this is separate. This one's
Well, I
think
think
it makes this
you talking about these two
here.
these
But they're trying to keep them in number
These
order.
two here.
And one, one. Like I'll just have two.
I was trying to look for that bridge.
Who did we use?
It's like a little around
No, because this line goes between them.
yeah.
So I'm looking for a line that goes between those. And I see this one right here, but it's not actually one.
Well, and you said one of them is like this bombarded with craters, it's like craters a lot of diamonds, a lot of them.
See, this looks good.
I don't know, I was trying to see, you see what I'm saying? Because now it is like this, like a huge, and then within it, there's more.
I see craters inside.
And those would be my credits.
What's this crater? That's actually a bacteria on the lens. This is, he said this is, he said, yeah, he said that was one. But see, this one looks like it goes up. That right there. I love it. Yeah, except for that one. It has a little zit. This one looks like a zit. See, it's except for the whole. And that's just like a just stick with it.
You are so middle school teacher.
But he said to get it to the middle school kids.
Yeah, see, I'm thinking like your elementary, I'm like,
Oh.
I feel like
This is about.
but have you ever done that? So you drop it into that expulsion and whatever.
Oh, yeah, we did a CSI.
For that, for us, the surface of
Maybe see the splatter. This one.
There's some elevation going on.
Okay, you had about 10 minutes. You probably, depending on the nature of the class you have, you may want to give them more or less time than I. So what I'm going to do is do things a little differently than they recommend here. Here, what the recommendation is of the activity is to have the teams convene as, you started off with 2 groups, and you broke them into teams, have the Mars group and the Earth group get back together and share, and then each individual 3 or 4 person team add your observations they missed to their journals. And then from there, pair each Mars team with an Earth team and invite each team to compare and contrast the features they observed. Then at the end of the activity, you provide each team with a sheet of poster paper and have them, or if you have whiteboards, just turn them loose on the whiteboards and make a list of different features and the similarities and differences they observe in each feature. Now, we have an awful lot of material to cover, and I don't really think we have the time to do that part. But what I would like to do, perhaps, is go through the pictures and have you guys give me some of your observations, and we'll see. When we get to the Mars pictures, we can do the comparing and contrasting sort of as we go. So this is the first Earth picture. Either one, which team did Earth? None of you did Earth. Okay, well that's my bad. I should have made you guys pick, so that we had at least one Earth team. This would be a volcano. It's a non-glaciated volcano. It's a, if I was a volcanologist, I could tell you what type of volcano it is. It's principally a liquid lava type volcano as opposed to an ash volcano. Those are the 2 main types. But if you're really into volcanology, you can say something about the type of lava. And I think this is Pahoehoe. And I suspect that, because I suspect this is actually one of the outlets of Kilauea. That would be the cheap one to go to. This, on the other hand, is Barringer Crater. This is the meteor crater in Arizona. It's only about 45,000 years old. It would have been unfun to be living near that, because calculations indicate that any human structure within 6 kilometers would have been flattened. And everything living within 6 kilometers would have been killed. These are high energy events. But so this is actually a meteor impact crater. Now, to be honest, this is. Is that the Great Wall of China? No, it's Grand Canyon. You can actually see the road leading up to the park right there. So, yeah, this is Grand Canyon with the Colorado River down in the bottom. Now, the interesting thing about Grand Canyon is at one point in time, the river started, those meanders are indicative of a flat, relatively soggy, soft soil when the river first started. Consider Louisiana, the lower Mississippi. That's what this looks like. In actual mountains, the rivers are straight. So this started life as a meandering river cutting across a flat plain, rather marshy. And only later, as it dug down into the rock, as the Colorado Plateau elevated, did it form this canyon. Um, that one's tough if you don't necessarily know what it is, because I'm willing to bet some of the children would put down tree branches. It's actually two river drainage basins in relatively dry climate, showing, or maybe it's taken with radar, so you can actually see all the topography. But these are drainage basins in a this is now they tell you this is Earth. This is an ash volcano going off, and in the polar region, so it is actually at least snow covered. You got two most likely possibilities. It can either be on Iceland or on Kamchatka. Those are the two regions most likely to produce this. Okay, this is what the Colorado and the Grand Canyon must have looked like 15 million years ago, before the Colorado uplift began. This is a meandering river. I don't know which one. Could be the Mississippi. That's another impact crater. The Earth has quite a bunch. We just what's the name of it? There's a big one in Germany, and there's a really big one in Ontario. I believe I'm not sure. This is obviously a volcano. Which volcano, I'm not sure. It could be Mount Rainier, it could be Mount St. Helens, but it's one of the Pacific Northwest Cascade volcanoes. This is a river delta. I mean, this is actually an entire river basin, showing. Anybody recognize where that is? But you can see the river, lakes. Those are probably man-made lakes with dams on the way down. And the river is flowing into a sinking alluvial coastline. And you can see forestation in the upper reaches, and Lord knows whether that's probably, I don't know what that, this camera is probably false color infrared, and I don't know, that it doesn't look cultivated. It looks, how can I tell it's not cultivated?
You don't see patterns.
You don't see patterns, you don't see roads. So I really don't know where that is.
Is that ice on the bottom left?
No, that's clouds, I think. So this is a volcano erupting. And this is an ash volcano erupting. And I think this is Mount St. Helens. What are those? Those are impact craters. Very old impact craters on the Canadian Shield. We all know what that is. That's Louisiana. That's the Mississippi and the Atchafalaya. This is another volcano, dormant. Don't know. That's also from Ontario. That's actually, that has a name. But that's a very, very old impact crater. Okay, so here we are on Mars. So we have 3 Mars teams. Anybody want to share an observation?
We thought it was a volcano.
Speak up, because I'm very deaf.
Okay, me too. We thought it was a volcano.
Yep,
That is a volcano?
it is a volcano, and there's some other features that you can notice. This is the summit caldera. Notice the scale. This is 100 kilometers across. So there can only be one volcano that big. That's Olympus Mons. But if you're just looking at the features, it's enormous. So with that being the scale, then these cliffs at the base are obviously very high. The summit caldera itself is tens of kilometers across. It has sub-craters inside it. The other thing you notice is it does not have appreciable amount of impact cratering on the surface, which means, relatively speaking, the surface is quite new. Now, another Mars comment.
Was it water flow of some sort?
Say it louder.
Water flow?
Water flow. This is a drainage basin. The water is flowing down on all these creek beds into this larger creek erosion feature here. And there's another such feature over here, but these are old because they're impact craters. Well, they're not altogether that old. Some of them are on top of these impact craters. These are impact craters that have water erosion features on top of them. See that? There's a water. That's where the water that ponded inside this crater escaped.
Do you think that maybe there was an ocean down there where
What?
it all fed into at one time? Where everything's feeding into? You know, all water tends to flow towards it.
You'll have to say that again louder.
Oh, I was just saying that since all water tends to flow towards, do you think at one time when Mars had water that could have been a water feature, an ocean or something on the bottom?
This could have been a lake or an ocean of some sort, yes. And this is the lowest part of this. And we don't actually see the drainage channels continuing.
Right.
That's the evidence it might have been an ocean. The drainage channels stop. So these are
Craters?
they're craters. The real question is what kind? I think they're impact craters. They're impact craters, but these features here are interesting because I think those are.
Sorry. Quick question. So how many types of craters are there?
Oh, 2.
Okay. It's impact and
Volcanic. I mean, the technical term for a volcanic crater is a caldera. But people tend not to use that term. I mean, the term basically just means hole. Actually, the root is closely related in Latin to the word for pot. So, but anybody comment on these features here? What might have produced them? Those look like water erosion features, the water flowing around the craters.
But it's not like running water, it's more like static.
No, this would be running water.
Okay.
Imagine running water going around an obstacle and leaving debris behind. Now this is an interesting combination. Note this is 50 kilometers. So this object here is fairly big. So what is it probably? It's a volcano, and that means that both kinds of craters are evident in this picture. Now actually there's a lot of features in this picture. So what do you see right there? That's the summit crater or caldera of the volcano. But the volcano also has craters on it which are probably impact craters. Now this area here is neither. If you look at that closely, what might have produced this feature?
Something pooling right there.
Not really. This is landslides and slumping, probably water erosion. You can see the landslides coming down off these walls. You can see water gullies. You can see this big slump. This is perhaps the third kind of hole. It's an area that's left behind when a landslide goes out. Because it doesn't look like either an impact crater or the caldera. Because you can see all this material that's just kind of slid. You've got drainage features. Now, drainage features near a volcano are problematic because on the moon, what forms them? Lava tubes. The lava flows out from a volcanic feature on the moon, historic volcanic feature. The surface lava cools, so you have a tube of lava flowing along underneath. Then the source shuts off, the lava drains out the end, and then over time, the roof crumples. So you have what looks like a ditch, but it's actually a collapsed lava tube. You can actually see those in Hawaii too. Here, that's more slumping due to water erosion or surface ice melting and flowing away. So you have virtually all the landscape processes we find on Mars shown in this figure with the possible exception of aeolian erosion, wind erosion. Comments on this?
Water erosion? Water erosion?
Water erosion. These are stream beds. Now, this is an interesting combination. What formed this in the first place? Impact. This is an impact crater, and what are these features here?
The splatter of the impact.
No, that's
Water
water going past. You had water starting over here and flowing off that way on both sides, carrying a bunch of the debris with it. Probably water erosion in here too. The wall slumping can be seen having been produced by water erosion. What's this? The real answer is we have no clue. This is why curiosity is in Gale Crater. The idea that craters have what appear to be sedimentary peaks in the middle is bizarre. So we have no idea how that formed. It could have been formed through wind-borne deposition of dust. So I guess one of the points here is you can teach a great deal about Earth surface science by this comparison. This actually fits in an Earth science class and meets a lot of your TEKs. Here we can see again a combination of this is fascinating. You actually have two what? Volcanoes. These are the calderas here and here. What are these? Impact craters. And then what's this? That's water erosion. And this is a lake that formed in the, and this is erosion. This probably was once an impact crater that became a lake, and then it's got eroded by the water filling it up and then draining. Comments?
It looks like a tributary, however you say it, like a lot of water drainage, erosion, different branching off.
The term we're groping for here is delta. This looks an awful lot, actually, like the Mississippi or the Nile deltas.
Just like the one you just showed on the Earth one.
Yep. Okay, this is another impact crater with water erosion features on either side. I think I've spent too long on this. This is, I think that the drainage was coming this way. And this is a carved drainage channel going out into an alluvial plain. Of course, what you're going to want to do with your kids is try and get them to talk through to some of these conclusions. I mean, I've spent 2 generations looking at pictures like this, so.
Is that drainage too?
These are drainage features being ordered by what was once an impact crater here with one of these really bizarre central peaks. And some of this stuff, these are extended lava flows produced by very hot, rather low viscosity lava flowing out large distances from nearby volcanoes. Another drainage feature, and this is a delta. It's coming down into this area here. Okay, that's going to be a quiz at the end of the period on this material. Okay, so that's quite an extensive activity. It's not part of our curriculum, but it's easily available if you want to use it. So finally, you asked the joint Mars-Earth teams to record anything they missed in their journals. and have them record their ideas in their journal. I don't know why I've got this in here twice. That's weird. Oh, that's because I'm going backwards. Oh, dear. Okay. So these are the questions they should be addressing in their journals at the end. Now, this is a talk by Walter Kiefer, who I often get to do the awards presentations at Mars Rover. He's based here in Houston. One of the things that's interesting about the solar system, and really hard to account for actually, are the different compositions of the different bodies. Mercury, for example, is much richer in iron and nickel, the core materials, than is Mars. Earth and Venus seem to have about the same amount. Mars, the Moon has virtually none, and Mars is intermediate. So you have a silicate crust, and you then have an iron oxide-rich silicate, and the core is an iron-nickel alloy and iron sulfide. Now, the Earth is big enough that the core itself differentiates based on various iron compounds, but Mars, I don't think, has gone that far. This differentiation took place within about 30 million years of formation. This happened very fast. Now, the differentiation releases a great deal of heat, which accounts for a lot of the subsequent volcanic activity. The thing to realize about Mars is you've got two very different hemispheres. The southern hemisphere is a highland. Note all the red. The altitude here is color-coded, except for areas like Argyre and Hellas, where the planet took a real heavy hit after the southern hemisphere formed. The planet formed asymmetrically, basically. You have a southern hemisphere that's high altitude and very, very old, rugged terrain, and the northern hemisphere this planar, low-lying region in northern latitudes is very imaginatively named. It's called the Planetas Borealis, meaning northern plains. Just sounds better when you say it in Latin. But it's a very large region of relatively new surface material because it's all been resurfaced since the late heavy bombardment ended. So somehow the lava that escaped the upwelling of the Tharsis Bulge, this whole region is the Tharsis Bulge, and these individual outlier volcanoes, and there's a big one over here too, by the way. That very much repaved this whole region with fresh rock, but it may not have been lava that repaved this. This could be sediment, because this low-lying region is where the ocean was. So the geology of Mars remains a very, very hot topic in research. And the hemispheric dichotomy is a puzzle we have no explanation for. This is the topography in detail I've already showed of the Tharsis Bulge and these 1, 2, 3, 4, 5 big volcanoes. And really, Olympus Mons is big with the threesome over here producing this entire Tharsis Bulge is bigger. Now, I don't know where that feature came from. That may be a relic of a very old but very big impact. It could be. Or it could be some sort of relic of at least an attempt to have plate tectonics. The Valles Marinaris is actually caused, we think, by this rock that underlay the Tharsis Bulge. As the bulge bulged up, you either needed to inject more rock or the rock was going to break. The rock broke. This gives you some idea of the size of Tharsis. You know, this guy, Olympus up here, is the size of Arizona. That would fit down here. But if you just put the Tharsis covers most of the western United States. It's enormous. Well, we've already talked about Olympus Mons. Here it is again. And there are other volcanoes out and about around the planet. This is a small one. We looked at the image of this in our image review a few minutes ago. It's actually Ceronius Tholus. Reasons your kids should learn Latin so they can cope as planetary astronomers. And this is Elysium Planitia. And I think some of these aren't actually impact craters. They're small volcanoes, like that one. But that remains to be determined. But the plane itself is obviously, there's a lot of volcanic rock flowed out over that. What accounts for this? The underlying circulation in the planet's mantle. The mantle is the region between the core and the crust. The mantle is hot enough that the rock is not really solid. It's not liquid either. But over time it flows slowly. And if you have compositional irregularities down in the core where radioactive elements are concentrated in one location and not in another, you can get the heat transport can take the form of not just conduction, but convection. Convection is what happens in a boiling spaghetti pot. And so we've got, there's the burner, and it's going up and rolling around. Now, on Earth, we have the same kind of thing. We have hotspots where there are sustained mantle plumes that go on for tens to hundreds of millions of years in the same place. The Hawaiian Islands and the associated Emperor Seamount chain, see, we get past Midway, all these peaks are below the ocean surface. But they all seem to have been produced by the same single hotspot, the one that's now. The Big Island has actually moved enough since it was formed that the actual hotspot's offshore, starting to form another island. One of the things that's interesting is based on chemical composition at isotopic ratios, we can form very good suspicion that some small fraction of the meteors that fall to the Earth actually were originally formed by blowing off pieces of the surface of Mars in high energy impacts. It turns out that the best place to collect those and be certain they're extraterrestrial in origin is Antarctica, because the ice sheet in Antarctica is several miles thick. You don't have handy access to pebbles. So if you find pebbles, you're pretty sure they came from space. And the surface flow and the sublimation patterns produce places where the flow of the ice gathers them together, and then the ice tends to dive or sublimate or something, so they pile up. So there are pile-up spots where you can just fly out to and pick up bunches. And we've been doing that now for about 30 years, and we got quite a collection. This is an example of what's called a shergotite, which is a particular chemical type of meteor. How do we know how old this stuff is? Well, once you form a mineral, all the chemicals, elements that are in it are in there to stay. And some of the elements that make up the crust of the Earth and the crust of Mars were, when they were formed in the stellar explosions that formed them, are naturally radioactive. What that means, but you can tell how many were there to begin with, because as they decay, they leave right in the same place a known successor. Radioactive decay tends to form elements. Well, the radioactive decay of a nucleus, that atom is going to stay where it was because it's in a crystal. It can't get out. So you can tell time by measuring the ratio in detail of the precursor, the radioactive element, to the end element. So we use that method, but particularly with our meteorites, to tell how old those rocks are. One of the reasons we want to get samples back, the radioactive dating process is actually hard to apply on a robotic spacecraft. One of the things we've learned from looking at these different planets, the Moon, Mars, and the Earth, is that the planets cool at very different rates. The volcanic activity in the Earth's moon almost entirely stopped 3 billion years ago, although there's some evidence that a couple of the volcanoes on the moon might still have some activity level left. That isn't necessarily clear. But these areas here, you know, I was talking about the drainage channels of lava that then had the roof collapse. That's kind of what you're seeing here. This is, well, I think it's a close-up of the caldera, the summit caldera of Olympus Mons again. And this is the Earth. And nothing after about 3 billion years ago. Some of the volcanoes on Mars were active within the last 500 million years, say. And as anybody who's following the news from Iceland and from Papua New Guinea knows, the Earth is actively volcanic today. The Valles Marineris is somewhere around 2.5 billion years old, and it was formed, as I said, when the Tharsis bulge formed and the rocks stretched apart and produced the cracks that we see here. Another comparison of Valles Marineris to Grand Canyon. There are two types of faults on planets. There are extension faults and compression faults. Extension faults produce ditches called graben, and this is basically what we're seeing at the in the Valles Marineris. The floor, the two walls are the result of extension, and the floor has fallen, leaving these 8,000 meter scarps. We don't see as much compression faulting on Mars. Now, once formed, the Valles Marineris has been modified by water erosion. All these puppies here are evidence of water erosion, liquid water flowing into the Valles. These slumping wall failures here, you may wonder why I was able, or even dared, identify some features as slumping wall failures, slumping landslide, because I've seen a lot of pictures like this, where it's obvious that's what happened. Here you can see the creeks on the wall flowing in and producing alluvial fans in the bottom of the canyon. Big landslide slump. So once formed, various other so now let's do another activity, and when we finish this, we'll have a break. I think this is actually my last activity, and then just talk. Well, I did promise to talk you through. Okay, so back up a few pages from where you were in this guy. I'll put it on the screen in a second. And you will find, and this isn't paginated, but you will find in there a page that looks like this, and the following page looks like this. Let me bring them up, because what you want to be asking yourself to do, you're reverting to childhood again. You are invited to examine the maps. So what do you observe? And on both of the maps. And what you want to do, and we have neither markers nor little paper red dots. Don't do it. Oh, they okay. Fine.
Stickers though, so I don't know if they want to stick them on the sheet.
So see if you can spot volcanoes on the map of Mars, and Um, you see any volcanoes on Earth that you can mark? So you're basically going to be marking the maps of Earth and Mars for volcanoes. So you have the map of the Earth, and you have the map of the Mars, and your first step is to mark volcanoes on Mars.
It's right here. You see it? And technically it goes around because this is actually connected. It's like this. It's hard to tell. It's
So, audience out in virtual land, I'm talking to the audience, the other audience, the recording audience. The people present are actually marking their maps with identifying volcanoes on the map shown on the screen. And I'm trying to restrain them physically from marking the screen with red pen. And for everyone who's laughing, how many of you have actually had the students do that?
mark the smart.
Yeah, with permanent money. Yeah.
Yes, this is something to watch for when you're doing activities like this. Keep them away from the screen. You may lose your screen.
Like there's a study room. Now we can compare the two sets. In the morning, solar.
Don't ever ask you to show you how high they can get you without. I had one punch a hole through the wall.
Are you serious?
Drywall, that's wrong.
No, I guess not.
That was an interesting conversation. What happened to it? He was once in a
Make sure you show.
What you should be doing now, when you finish marking the volcanoes on Mars, the Earth is somewhat bigger. See if you can spot any volcanoes from space.
You said this is a picture from.
This picture is taken from space.
Is that right?
Actually, this is a composite. But
I was being serious.
Yeah, I think they took all the clouds out. Because there's no way this is not gonna be any clouds.
if you take pictures long enough, you'll get a picture of every place on Earth with no clouds. They've been doing this for nearly 50 years. You can produce a cloud-free composite.
So we're looking on this map and we're looking for volcanoes, right?
Volcanoes, yeah, can you see volcanoes?
I see them. I see them right there. By Africa.
Oh, right in the middle? Oh, no, Africa.
Edge. Ring of Fire right there, then under. Can we zoom in to help us with the?
You know, since your kids are getting what are known in the trade as pieces of paper in the classroom, besides, this actually doesn't have that much zoom capability.
I can't.
Can I zoom? Maybe let me see if I can zoom in on this screen.
Maybe this is
I see something, I don't know, those are islands right there by Africa, the top part of Africa.
talking about Fiji.
These, right, I mean, you can't, I always say 60 degrees. Yeah, but right here, you can see something all in the middle, in between North America
I mean, let me look at my cheat sheet. Hey, you know what? You're right. That's either a smudge or a volcano.
but it's a lot, when you look, you can see.
No, I can see it here. You are right. There's two smudges and there's smudges here. if we could zoom in and increase the resolution.
Pretty much your class. Pretty much every item we see there. We don't have your faces, but. I know.
Yeah.
I don't even have to, I have to share. I have to walk every single day. But I don't feel like.
You get your stuff.
Yeah, so the teachers told me I just sit with the laptop and I connect straight to the printer in the workroom. And so I don't have to go to the print. Send it to the printer and it'll just paper it in and take it in. And I'm just sitting there.
Okay. I think we will
I don't consider it work.
take that down. So you've
So what should we show our students?
There's a lot of them.
All of this over here?
Yeah, we're gonna try to do.
okay. What I'm now supposed to do is you actually have the next 2 pages. So if you turn to the next 2 pages, you will see maps of Earth with and Mars with the volcanoes marked. And so you're going to ask the question in class, what does the map of the Earth show? How does the number of volcanoes the children identified on the other map of Earth compare with this map? And the same question for Mars. And so here's the map of Earth. Now the children are going to get very few of these. If you've discussed Hawaii, they'll spot Hawaii. Some of them may know about Iceland since Brottharbunga is in the news right now. And Iceland is basically one ginormous volcano. Very few people are going to realize that New Zealand is mostly volcano, and very few people are going to realize the extent of volcanism in Kamchatka and Japan.
Question, which one is Greenland, which one is Iceland?
Which one is, oh, okay. The question is which one is Greenland and which one is Iceland? The big feature is Greenland.
Yeah, that's what I figured.
This is Iceland here.
It's just interesting how they call Greenland.
When Greenland was discovered in the 11th century, we were in the middle of a warming period in our climate, and it was actually much more amenable to agriculture than it is now. And you had people coming from here to Iceland, and they didn't really realize that the current systems were bringing warm water from the Caribbean. The Gulf Stream was basically bathes England and Scandinavia in warm water, but not over here. This is colder water, so the climate's much colder. It's interesting to look at think about the fact that we're at the same latitude as Cairo. Do you ever think about that? We are the same latitude as Cairo. London far northern Quebec and northern Ontario. Basically, London's at the same latitude as the southernmost tip of Hudson's Bay. My daughter spent a year in Berlin, and which is in here. Berlin is about the same latitude as Quebec City, maybe a little more further north. And she was amazed at how long it stayed dark and how grim the winter was. Okay, so that's the children are not going to have gotten many of these because they're not obvious from space. Partly that's a matter of scale. All of these volcanoes are smaller than the Mars volcanoes, and partly it's the Earth is so much bigger that to put it on the same size screen, you end up with far less detail.
Did we also get less foliage on Mars, so it would get better?
So there are far fewer in Mars. There are really a lot fewer volcanoes in Mars, so you can see pretty much all of them on a global scale. So that's kind of the difference. So the students can make observations. There are much fewer volcanoes on Mars. They're much bigger. They're all shield volcanoes. Earth tends to have volcanoes in long lines. And you can see the patterns are much clearer on Earth because there are more of them to make patterns. And then you could ask them all these questions, and they can put that in their notebook. So, and then the students should ponder the differences. Why might they be? Okay. Now, this is a good place for a break. We've been going for an hour and a half, so time once again for human element range extension. So 10 minutes. And for those of you who have been wondering, when is he going to show the results from Curiosity? Not being a fool, I show those last.
Two combinations of the yeah, 60 cents. And sports event last year. The biggest engineering the kids not only competed, but they also all those college students just put out their innovations and inventions, the physics. So the kids got to go around and experiment, touch them, check it out. It was interesting. They had a bike that was all wood and it was square tires. But the track to get to work, we had to actually have the track symmetrical, basically stuff, you know, and literally you could just, it's smooth, you could just, no effort. But, yeah, it never happened because you would have to change over the road. But just to think about the possibilities, you no longer have to do it regularly. Running on the square tire. But there's all kinds of well, I had elementary. Yeah. It's called Smart Conference. Type in A&M Smart. You'll see it's on November 22nd. I think the elementary is 5 of us. I think the elementary is 5 of us. They pick one team. And then the beginning is you get your badges and everything, and then you do a all the costs. And I think you eat lunch. So you do a competition. And then you get a tour of the campus. And then awards. Well, it's $15 but it covers your lunch and you can get a t-shirt. So it's a non-profit. Yeah, right. But they and then also buy the shirt for they get a t-shirt and they get their lunch. So it's pretty much covered. Yeah. But my campus we're paying for But it's worth it. They get to go to a university campus. They get to see college students showing off their stuff. They get to compete. It's very enjoyable to see encourage kids to especially if you're trying to bring STEM onto it. We did the oil rig. The kids are building they get hit with money. And they get time with the strings. And they do it. And so you have your supplies. Yeah, because I have a class. But you can do it.
Did you? Okay, I will make sure you get. Okay. I'm not worried about the CEU. It's not.
We want to which is pretty amazing. But my team lead just
Alright, cool. Email me if you need anything.
they decided to use magazines. It was less friction. And newspaper also bends. So my kids came up with strips. They did this all on their own. They cut out strips to hold the newspapers together. So it would form the walls. And it was just little loops. And then they used
That is cool, man.
It's called zip.
They built their own
Zip
system.
cord.
And, you know, it jumped
So you put it in there,
track,
so I'm gonna have one set up, and so when they do something, they'll take a picture of the
Then
actual
when they went
test,
to
they put it
competition,
on copy that way.
Right.
But they're also
they
scored.
gave them this much paper,
That is,
and they let them use paper tape. How about that?
talk about saving time.
One
Then
sheet.
they copies, you know, once they do
Right
that,
there.
And,
Yeah.
and you don't have to go and get one of the other. They also do
I told them,
segregation
this is what you guys
and.
do.
So cool.
Problem solvers.
Technology
Once
is
they were ready, they came in there with those
fantastic.
constraints,
Yes.
and they just started using
Yeah,
very
sometimes it can be
you
driving
know,
crazy.
and,
2 months.
and they said if you buy tape, you know, you could buy a tape and use it.
Yeah.
So you could buy.
That's the wonderful part.
Yeah.
They go to the
And
museum.
someone asked me.
No, this was the A&M engineering exercise. We won third place.
And he was out there.
So
and
it was,
Yeah.
Okay, that was the
Yeah.
one you were talking
And
about.
yeah, these
keeping
kids, there was
things
8
on,
kids,
you know it all.
and I was just telling her that A&M gives you
Well, I
a
think
little
like
bit
it
of
when you
information,
come to because you.
but they
because
always
you
just
know,
twist
you know, wherever
because
you're
they get
working
trained
and
for it.
stuff.
We practice. I had the kids.
Benefit of-
I taught the kids.
It's fun.
First thing I taught them before we even did Rover was
It shows
assembly.
support.
Exactly.
And I told them, and the way my class is structured, if you go on the website, you'll see it. It's we're going against they're agents. So my 6th graders walking, they're all agents, and they work under this Agent Chance, who's a puppet,
Okay.
and they're going after 2 characters, Mr. Sinister and Dr. Malicious. They're evil guys.
Okay.
And so in the beginning, it's a and I have a news. You'll see if you pull up the website, you'll see the headline news. And it talks about Dr. Militia's been recruited, and he's now using magnets to track meteorites and target DCMS training facility. I mean, it's just yeah. So the kids are all like, and so the first mission was there's videotapes of them stealing all the training.
There you go. Oh,
So there's a
everyone's the exact
you
amount.
can watch
I didn't
these
even
YouTube
worry about
videos
things
of
today.
the kids just running off with the supplies. And so one of the first missions that they had to do was using a stick.
And my email is just Mars
They had
Rover
a pan. And using, I got meter sticks,
Yeah.
and they had to come up with as many ideas of what to use a meter stick in teams of 4 without giving up, and they would rotate. So whatever they wanted to use it for, they had to come up with ideas. And so, or motor or whatever. And so I would sit as a judge, and I would be like, all right, and they had team names, so I'll go team 1, and they would come up and they would say, stir and hot. Team 2 and team 2.
Okay.
They said the same thing.
Now we're going to get down to. I didn't get. Some people left before I got to my hot latest results.
Yeah. They're not gonna be in the loop.
What?
I said they're not gonna be in the loop.
They're not going to be in the loop. Like all speakers, I save the best for last. With reason. Okay. It is getting late, so I will move briskly through my next 100 slides.
Just do all the evenings.
All right, so I'm going to talk about Mars exploration from a mission-oriented perspective. So we'll all move down the street to the mission San Gabriel. No, never mind. That's a California joke. There are a variety of missions currently orbiting Mars or about to orbit Mars. This is the Mars Reconnaissance Observatory. This is Mars Express. Well, I should probably do this. Mars Reconnaissance Observatory, Mars Express. Odyssey, I think. Actually, and this is opportunity, and this is curiosity. And I'm misidentifying one of the orbiters, but never mind. We have 3 active orbiters. I have a feeling that these we're already into slides that I didn't get to Laura before she went to the printer yesterday. There have been 42 missions to Mars, 20 from the United States. 21 have succeeded, 15 from the United States. There were some dark decades. 1980s, we had no missions. 1990s, most of them failed. There are 5 current missions, 4 U.S. There are 4 future being, in the case of 2 of them, 1 U.S. and 1 Indian, the future is in the next day or 5. There, I mean, the Mars orbit insertion countdown has actively begun for Maven. So, in the 19th century, and in the 20th century, early 20th century, people thought about the possibility that there were advanced civilizations on Mars. This is mostly psychological wishful thinking on the part of, see, all these maps were drawn by people peering into the telescope, looking down at their notebook, peering into their telescope, looking down at their notebook. And it's upside down because that's what telescopes do. So this is actually the southern hemisphere. So they kind of got Hellas right, but that's about all. Carl Sagan in 1975 said something very profound. He said, "To only one generation in human history will it be given to be the first to explore the planets. For one generation, the planets will go from being distant, remote, unknown lights in the sky to familiar, exciting landscapes in the process of exploration and revelation." I add to that, to becoming valued old friends whose portraits hang on your dining room wall. Carl didn't quite get it right. It's taken 2 generations. Luna 1 landed on the moon in 1959. We don't work like that anymore. That was 2 years after Sputnik. Just 2 years. Mariner 2 flew by Venus in 1962. Mariner 4 went by Mars in 1964. That's 5 and 7 years, respectively, after Sputnik. What? We couldn't do that now. Next, July 15th, New Horizons flies by Pluto. Mission accomplished, Carl, sir. Of course, that's 40 years after he wrote those words. I'm not sure he realized it would take that long to get to Pluto. The exploration of Mars has occupied most of that time. 2 generations, 55 years. It spanned my entire career. I was starting high school when Luna 1 landed. I was a junior in high school when Mariner 2 flew by Venus. I was a freshman in college when Mariner 4 flew by. I was actually taking Astro 1 from Carl. I didn't call him Carl then either. This is my college and graduate school career, watching these guys happen. when the quote I just gave you from Professor Sagan was written, I was a newly minted assistant professor here. And year by year, we've watched the wonder unfold. Mariner 9, 1971, I was still in graduate school. This was the first orbiter. I think Mariner 1 actually arrived during my honeymoon. Do you have any idea how hard it is to find a space news bar in Switzerland? Or rural Norway? You just can't do it. Viking 1 and 2, I was an assistant professor. And I was actually teaching Astro 1 here. And that's challenging because for budgetary reasons in those big courses, we print our homework at the copy center before the semester starts and hand them out as booklets. They buy them. You get your homework booklet for $15, you know that. On at least 3 occasions during the 2 decades I taught that course, I prepared, wrote, and disseminated a homework that had no valid answers by the time it was due. That tells you how much these spacecraft changed our views of each satellite each time they flew by. This is Olympus Mons as we first saw it. This is the very first picture from Viking 1. This is Chrysae on the ground. And what you have to understand is that these rocks are a few inches across. And the horizon, given how that may have been 3 or 4 feet tall. The Russian Phobos probe crashed. Mars 96 crashed. Mars Observer crashed. For a variety of different reasons. One of them, I think it was this one, crashed because the contractor, one of the contractors used metric, the other used British units, and they never discussed that fact in the software. So they just missed. Finally, in 1996, we got it right. We put another lander down. And little Sojourner, which lasted 90 days, which was its design lifetime, little Sojourner is about the size of that. It's a tiny little thing. And the American people fell in love with this puppy because it looks like a puppy. Wouldn't you want one running around your house? It could be your Roomba's pet. The Roomba needs a pet, right? So Mars Glover Surveyor was an orbiter that got, and it measured magnetic field, gravity field, atmospheric conditions, long-term seasonal changes, and it look at this, look at this. These are gullies, and from one mission to the next, over a span of a decade, those gullies were changing. Water. Mars Global Surveyor lasted 9 years in orbit. It's one of those annoying things that happens when it disappeared. The media, you know, there were writers in the media who got all huffy about NASA can't do anything right. It'd been there for 9 years. Its design lifetime was 2. Mars Odyssey arrived in 2001, and it's still working. It's mapping minerals, and we remain in service because, well, you can always take more observations because I'm not sure it's actually passed over 100% of the surface yet with every instrument working. And it also carries what all the other orbiters carry nowadays, surface probe relays. So the Curiosity relies in part on Mars Odyssey to get its data home. The new thing that Mars Odyssey had was infrared spectroscopy. And also very fine resolution altimetry. So we started doing really good contour maps and coupling those contour maps with maps based on infrared spectroscopy of what the different types of minerals are. So now we're starting to do surface geology and the surface geological history of Mars. And there's an enormous amount of knowledge that's built up over, we now have some idea of the different periods from which these different types of rock come from. The gray, or the beige and pink minerals are particularly unlikely to have come from anything but an aqueous environment. Mars Express was a European Space Agency mission. It had a lander called the Beagle, and the Beagle failed for a very interesting reason. It had a sensor that basically said, okay, if the legs open so far, it's on the ground. At that point, I'm going to turn off my descent rockets and let the chute go. When the legs sprang open, they went that far. So what it was detecting was its own landing gear opening, not the ground. And so the Mars Express, the orbiter is working great, but the Beagle, not so much. This is the kind of data returned by Mars Express. Down looks into these very deep valleys with a whole lot of different instruments working, and you learn a lot about. You can see the floor is flat. That's indicative of sedimentary rock formation. Now, the Mars Express has what's called the high-resolution stereo camera, which actually lets you take three-dimensional pictures, and you can get them on the NASA website of these features. And this is their perspective views. You can then print them as perspective views. So the perspective view was created from a digital elevation model, which was in turn created by the high-rise stereo camera. So I think this is an actual image. This is an image. And this is a perspective view created by a computer based on the stereo camera data. Mars Express also has a radar, which is used for penetrating the surface. And you can see this image here. It's a radar image of the southern polar cap. So you can see the underlying rock and the thickness, the underlying rock and the thickness of the polar cap. The most recent orbiter until tomorrow is MRO, the Mars Reconnaissance Orbiter. It has the best camera of all. It is seeing a dinner plate. MRO was the one I forgot about when I was looking at the 5 active missions. Interestingly, MAVEN will not have a camera. It's fundamentally just an atmospheric mission. And now roving, we have Spirit and Opportunity. We're going to see a lot of imagery from MRO because they use it for navigating for Spirit, Opportunity, and Curiosity. In fact, it was this project that provided the impetus for this curriculum. And this is an old photograph. That's Pathfinder, you know, the puppy. And this is Spirit and Opportunity, both. They were identical. And this is actually a third one kept in the lab. So where are they all? The okay. Viking 1 landed there. Mars Pathfinder landed there. Viking 2 landed there. Spirit was in Gusev crater, and Gale crater is right here. Pretty low lying, actually. So, Spirit landed in Gusev crater, and this is a picture from Spirit, and it's probably a former lake in a giant impact crater. You can see the drainage feature. Actually, I think that was water flowing into. One of the interesting things about Mars' surface is it's covered with sort of loose boulders and pebbles. Probably debris from impacts. But some of it's obviously produced in more terrestrial-like ways, namely river transport and so forth. So this rock was sampled by the probes on Spirit, and it was determined to be basaltic, which means it's basically lava of a kind. But this is looking at the track of one of the rovers. That's gypsum. Gypsum is a mineral that requires the presence of water. Opportunity sent this picture early on. And it looks like this massive cliff. That's all perspective. If I was standing here where my pointer is, that would be waist high. This is actually a rather small feature. So we began to see signs of water in the surface observations by Opportunity. These are little hematite nodules that only form when the mineral itself is deposited in water. And we have similar nodules on the Earth. New England's got tons of them. And then you look at this rock, and this rock was formed by mud hardening. You can just tell that looking at it. So here's that feature I showed close up a few minutes ago, and this is a panorama. Remember, that's about 3 feet high. It's rugged, but it's not that rugged. It just looks more rugged than the... And so this is a mosaic of a region that was described by the investigators as the upper dells. These look like what sedimentary minerals laid down in an aqueous environment. These ripples are actually evidence of wave action. The first of the second crater, the first big crater visited by Opportunity is Victoria Crater. It went down into Victoria Crater some distance to observe the sediments here at Cape St. Vincent, which is the name of this feature here. And one of the nice things about craters is they're instant excavations. The sedimentary rock that the crater fell into, and that's an interesting factor already, that by the time this crater was formed, there were already hundreds of meters of thick of sedimentary rock at that location. And this is a rock target, again, being investigated by Opportunity, called Esperance. And it was the investigation with the tools that they have on Opportunity indicate is a wet, let's see, what did they do? The data was taken from the alpha ray particles, alpha and X-ray spectrometer, and this is higher in aluminum and silica and lower in calcium and iron than other rocks. So this mineral content has apparently been altered by intense encounters with water. Now, after Victoria Crater, the Opportunity schlepped off for several kilometers, took several years to get to Endeavour Crater, which is about 20 kilometers across, a huge crater, and they're now exploring the rim. And this is Cape York, and this is what's called Scholander Point, and there's some opportunities now down in here someplace exploring Scholander Point. They spent a couple of years tooling around Endeavour Crater. They've actually gone down into the crater itself to some extent. They went further down into, so this is their traverse over the Cape York outcrop. The left-hand side is outside the crater. This is the interior of the crater in here. So they're really going in and out of the crater, examining all the strata that have been poked up, doing quite a lot of geochemistry. And now they're approaching Scholander Point. I think they're actually up on top of Scholander Point right now. And they have a terrific view. And if you go to the Opportunity website, you can see some of the photographs they're taking. Okay, so after those landers, Phoenix in 2008 landed. It lasted one season. It landed at the North Pole, dug into the surface to analyze ice, did a lot of in real-time surface chemistry, and then the winter killed it. And this is an artist's conception of what Phoenix looked like working. And we weren't that far north. We were far enough north that it wasn't going to make it through the winter. And right under the surface, dug down, there was ice, water ice in profusion. You can see right there, they're cutting into water ice with their sampling. Ah, I knew there was a slide I needed to update, Laura. Curiosity is 2 years old. Okay, so, and it's beginning to show road wear. It could use a tire change. The left front wheel is really taking a beating. The 6 minutes, was it 6 minutes or 7 minutes? 7 minutes of terror. That was, I was playing golf. I could, it was, okay, here's how you really learn calm and focus. Play golf during this. So we have cruise stage separation. This, now I was actually on the down select team that picked Maven, the spacecraft that's about to enter orbit. There's no way we would have picked this. No way. Okay. They flew down with aero braking, a heat shield, hypersonic. This hypersonic aero maneuvering, they were actually flying back and forth, trying to A, refine their target, but B, to lose velocity by making S-turns, which is what the shuttle does. Eventually, they deployed the parachute, dropped the heat shield, started getting radar data, and then the back shell separated with the parachute, and a rocket motor. This is the classic space science fiction landing of a rocket ship, except that this is actually a crane, and at some point it started to lower down the payload below the rocket ship. And when it detected that the payload was down, the rocket ship released and flew away. They're trying to minimize surface contamination owing to the landing. I've met the guy who designed this, a guy named Adam Stelzner. Don't ever let him design your car.
Yeah, I met him too. He was at the cast.
Yeah, he was. He spoke at CAST last year. All the folks who drive Curiosity, they have a game. You know the game Cards Against Humanity? Oh, you're well off. It's rather an abusive parlor game. And they have a version, Cards Against Mars. But in one moment in a fit of jocularity, when I was about to go to CAST, I said, you know, this acronym makes me think Cards Against Science Teachers. And my former student, who is the author of Cards Against Mars, said, oh yeah, we have that too, and gave me a link. I was kidding. No, we're not. Anyhow, so if you really, feel you need to reduce your self-esteem, you can get yourself a copy of Cards Against Science Teachers. So Curiosity, this was not an accident. This was timed. They actually took a picture with Mars Reconnaissance Orbiter of Curiosity on the chute. Curiosity itself took a picture of its own heat shield falling away. Their onboard estimates, they were trying to get, because of the complexity of the terrain inside Gale Crater, they were trying to hit within a kilometer of their estimate or less, a few hundred meters. The entry target was there. The onboard state estimate was there when they pre-entered. They came closer than that. And these are the comparative errors of Viking. The length of the ellipse is the direction of the velocity vector, and they were actually coming in this way. The width of the ellipse is side-to-side steering, and this is their prediction error that they're working with. Improvement every step, but still, see, they were trying to get close to this peak in the middle of Gale Crater, which is scientifically bizarre. We do not understand how it got to be there. So this is what they actually achieved. This is again from the Mars Reconnaissance Orbiter. There's the heat shield. There's the back shell and the parachute. And there's Sky Crane. So coming in like this, from down there over to here. This is practically the first set of pictures it took. It used all its cameras, sort of all of them looking back at itself, and took a self-portrait.
Took a selfie.
A selfie, yes. This was its first panorama. There's Mount Sharp. Now this is Mount Sharp is where they're going, and they're now over in here, getting close. This region in here is a dune field, and they really need to kind of avoid it.
Why is it blue?
What?
What is the coloration? What minerals do they think are present?
There are various forms of hematite, really. I think, I'm not sure why the black sand. That's an interesting question, and I don't happen to know the answer. These are details of the layering that they're going to they really want to get up in here and investigate this layering. All this is a sedimentary mountain in the middle of an impact crater. Nobody understands how that occurred. It's a fundamental mystery. So Curiosity's first month, a certain amount of this discoloration is simply from the sky crane. And the initial landing spot is named after Ray Bradbury as Bradbury Landing. Yes. Now, during the first 90 days of this, she's since moved on. She's now the driver of Dawn, the ion engine powered spacecraft heading to Ceres. Elena, did you meet her? Carrie Bean, she spoke several times.
I think so.
She was a graduate student at A&M and an undergraduate at A&M, super interested in this program, and she volunteered, and I asked her to actually speak at the awards ceremony because I felt like, well, okay, an eighth grader can relate to an undergraduate far better than they can relate to one of us grubs. And Carrie, okay, I got to set the scene here. You read this, and what do you expect? Well, I think some of you have seen the pictures on the news of some of the crew, and you probably expect Bobak Ferdowski, the guy with the mohawk. His Twitter handle is Tweets Out Loud if you want to follow him. So you expect somebody like Bobak with a cut-off T-shirt and tattoos, right? Who else would drive a giant atomic-powered, laser-armed robot? Carrie is 5'3", maybe 5'4", thin for her height. She has long, straight, light brown hair, wears John Lennon glasses, and, okay, for Halloween she plays a mean Miss Frizzle. She has an R2-D2 dress. Am I conveying this person? Okay, so when I introduced her to the awards ceremony last time she spoke, I showed this picture because she had spent 3 months being the driver for Curiosity because of what her dissertation was on. And so I said, I show this up and I say, okay, and here she is. They're all expecting He-Man with tattoos. And in walks this very petite, nerd to the bone, obviously, young lady. And all the girls go, oh my God, that could be me. Yes. So what's Curiosity discovered lately? The isotope ratios, and they're now in a position to detect isotope ratios. The atmospheric loss has been to space, not to the ground. It happened during the first billion years. The light argon isotope was also lost. I showed you a video of whirlwinds. They've also been detected by Curiosity. We found a bunch of rocks that are streambed gravels. 3 pavement-like rocks, congealed mud. That's what I'm talking about. the stream flow, and they can tell from how the rocks look, was at least 1 meter per second, and it was angled to hip deep, and it lasted for months. And these are minima. So we're talking about a waist-high stream flowing fairly fast for a long time. So Curiosity, Glen Elg was the first place they did a whole lot of surface investigation. You always want to do some heavy science early, in case things quit. So then after they did a lot of work at Glen Elg, they changed into travel mode. They have 8 kilometers. They've done those 8 kilometers. They already discovered that Gale Crater once was a lake, and a lake with a benign aqueous environment. That's fascinating. This is the first anniversary panorama. These are the so-called twin cairns. Most of these names don't mean anything. They're just what, well, I don't know who actually comes up with them. I have a suspicion. The guy who actually makes the maps and makes a lot of these pictures is a guy named Fred Califf, and his ID on Twitter is Mapperwocky, which tells you something about his personality. I've actually met him. At the 1 year anniversary, they traveled 1.6 kilometers. They connected to 190 gigabits of data. They fired that laser 75,000 times, and they basically drilled into and really chewed up 2 rocks. And they'd already achieved their primary science goal. They've seen some neat things. I believe this is Phobos eclipsing the sun. They actually got a movie of, and I don't think that this is a movie I have, but let me try. Nope. NASA actually has a movie of that picture showing Deimos and Phobos passing each other. They also got a Christmas Eve shot of Earth Sept. They could see Earth in the distance, and it was setting in the west as Mars was turning. Now the main goal is to learn if Mars could have supported microbial life. This is some idea of the extent of the ancient lake in Gale Crater. Remember that Curiosity has landed in here and is trying to get around over to here. Rover tracks in difficult terrain. Okay, the first trick is to spot them. They are in the middle. Okay. There's the rover. And there are the tracks. And yeah, I'm not quite sure where it goes. You sort of lose them as it goes off up here. That's mostly because, well, this is hard rock. But you can see, and it went over this way, and I don't know where it went. Up in here, oh, there's some. Very difficult to spot. But this is the kind of terrain, this is the kind of image that the drivers are using to plan the path for the rover. And this has been complicated recently. Another view of the rover. There, you can see the track pretty nicely here. And the rover is, I think, in here somewhere. And this is a feature which has some kind, maybe it's come, do we see it? Oh, there it is. Okay, yeah, it's over here, and it's come from over here. And it's at a mountain a small hill called Shaler. I don't know what these names mean. I do have a feeling that there are a bunch of 20-somethings at JPL having fun assigning them. And if you actually want to get this picture, this is a billion-pixel view from one of their many stopping points called the Rock's Nest. And it's an interactive. So it's an interactive 360 panorama. So you can scan through it, dive into it. A billion pixels gives you a lot of image depth to examine and explore. So we're still on the road to Mount Sharp, and this is sort of as of June. So as of June 12th, they were here. And one of the waypoints where they stopped and tried to do a bunch of science is this spot called Kimberley. Darwin, Cooperstown, Kimberley, no real meaning. They're headed these are the Murray Buttes, and they're going to turn either around this side of the Murray Buttes or on this side of the Murray Buttes and head uphill. These black sand dunes are not really good travel. They tried to get into one of them back in somewhere around Shoshone. They're just about, where are they now? They are just about, Murray Buttes are there. Talk to me. I think they're either in this depression or in this depression right now. But you can see the terrain variations that we are facing. You know, the dunes and the soft sand and the hard pack and the really kind of very sharp, rugged rocks. And this isn't the best of the, or rather the worst of the pictures of wheel damage, which you can see right there, for instance. And right there, this wheel is taking a beating. And there's been a more recent picture of the left wheel posted on the internet. If you follow the right people on Twitter, you get these every week or so. The tires are really taking a pounding. Now, it is true that the design lifetime was 2 years and they passed that. But they rerouted after they realized how much of a beating that the tires were taking. They rerouted into a gentler region, and this dune here, they did cross this dune. This is a place called Dingo Gap. To get into the gentler region they wanted to go. They were kind of leery of crossing that dune. And so this is sort of a pseudo video made of a series of stills, so they're actually crossing the dune. Now, one way to reduce the wear on the wheels is to drive backwards. And they started to do that. But now they're looking back at Dingo Gap and looking back at their own tracks. They go a bit slower. So this is the route they took. This wasn't their planned route. Their planned route was more across this way, but they started to take a longer, softer route through some of these gaps, like Dingo Gap was here, and they're going to eventually go through some of these much more gentle to this region called the Kimberley, where they spent about a month and a half doing geology and such. So here they are at the Kimberley Waypoint, and a lot of my Mars geology friends just went nuts over this rock formation. They thought it was really luscious, to quote one of them, which made me think that, you know, Emily's diet is too strict. So you can see differential wind erosion on some of these rocks. A lot of this is wind erosion that you're looking at. So they stopped and did some drilling and examined stuff. So here's the Kimberley, and we're looking. This is the region that they call the Kimberley, and the picture we were just looking at was from here, looking that way. And they found a rock they enabled Winjana, or Windiana, and that particular rock, they drilled in, they did some chem shots, and I think they took some samples of the drill detritus into their sample analyzer. And this is actually a picture of exactly where it was. If you can spot it, I prepared a really major talk last summer, so, oh, there it is. On June 12th. Amazing you can see it. So now the official end was on June 24th, and they have been approved for a 2-year extended mission, although it was close. They didn't take the review seriously enough, and the review panel savaged them. They came in last in the senior review. And if Congress hadn't been really generous, they would have been turned off, effective 1 October. Now, I don't think the public would have stood for that, but that was what the scientific community was about to do. There's nothing more vengeful than a slighted review panel. Always be polite to your reviewers. So we're going to do basically stratigraphic geology going up Mount Sharp. And we're also going to feed forward to Mars 20 to help them optimize their strategic plan. So now this was day 660. This was in June when I was preparing this talk. As the day I prepared this talk, they were there. And we'll see where they are now. I don't think they're going that way. I think the plan has changed, because they are, I think, right in there. I think they're going to go around this way relative to Murray Buttes. So here's the end of the dune field, and these are the lower reaches of Mount Sharp. And how do we define the base of Mount Sharp? We define the base of Mount Sharp as the boundary between rock that was laid down as part of the process of laying down Mount Sharp and the pre-Mount Sharp floor of the crater. The words you can't read say, "It's why we came." And you have to recognize that some of these little rocks out here are the size of Curiosity. The going is going to be a lot tougher than it was so far. You know, we've driven 8 kilometers. Oops, let's see. Yeah, that boulder up there is the size of Curiosity. The one you can't barely see, that one. Now this is a false color showing geological provinces. This is an image from that infrared spectrometer overlaid on a visual image, and this is the Murray Buttes area. Now the plan that you saw on the previous slide was to go around this way, and I now think they're going to go this way. Where did they come up with the name Pahrump Hills? I don't know. I mean, Murray Buttes are named that because somebody named Murray named this geological formation, or was named after him. But the edge of the Murray Formation rocks are the official base of Mount Sharp. And we got there last week. Now this is quite interesting, and I can't see it because it's down off the bottom. The detail here is actually down in here in the Pahrump Hills. But this spot here, you'll notice more than a month went by and they were basically in one place. This valley here that you can't see at the bottom of is loose, looks very flat in the pictures. It turns out to be very loose sand. And they went in and got stuck. And you don't want a $1.5 billion rover stuck. So they gently backed out and tried to do some drilling here, and the rock proved unsuitable. And then after screwing around for 40 days, there's something canonical about that interval, they then went around, and they're now, this was 2 or 3 days ago. Okay, this is a detailed picture of where they are now. You can see the track. This is where they tried to go down this valley. It looked very inviting, a very broad, gentle, flat valley full of very soft sand. So they had to go around this way, and they're now here. And the Murray Buttes are over here. These are the Pahrump Hills. And they're right on the boundary between the Murray Formation and the rocks of the crater floor. Yeah, they have changed their plan. See, the picture I showed you from June, they were going to go around this way. They decided to go down this side of the Murray Buttes and then head up this. You can see there's a break in this ridge. Some of these escarpments are pretty damn big, steep cliffs. Let's back up. That doesn't look like it'd be any fun at all to go up. They are going to go kind of down and around and hope they don't find any more real beds of soft sand, and then they're going to go on down this way. But you can see some of these, we're starting to get into regions where there are big hills and steep cliffs, like right there. That would ruin your whole day if you went off it the wrong way. So they are, they're going to, they're kind of up in here right now, and they're going to kind of go sliding around. This is the end of the sand dunes. There's this. They're going to see if they can get across that sand right here, and then you can see this. They're switchbacking here. This is a steep hill. So what are they? What's the future of Mars exploration? Follow the water to potential habitats. So we want to know how much ice and liquid water are on Mars today. There's still evidence there's liquid water from day to day. That we still see 5 years ago today comparisons of places where gullies have appeared in the camera data. So these are the questions we're still investigating. And let me remind you of the Maven flyby, which is tomorrow night that's Eastern time, that's UT, 5 hours, be 8 o'clock, 8:50. The next mission after Maven is InSight, which is going to launch in 2015. It's a stationary lander designed to do deep exploration drilling. The current target for the manned Mars mission is 2035, which makes me mad because I am actually working on the propulsion system for the manned Mars mission. I started 20 years ago. And 20 years ago, the target, we were going to launch the cargo mission in 2 years. And the men were going to take off on May the 5th, 2018 at 11:10 in the morning, Central Daylight Time. I'm going to be 89 when this puppy goes off.
Guess you're not going.
Well, I'm probably not going, but the good news is all 4 of my grandparents live longer than that. Okay, so that is it for today, boys and girls. So I'm done 40 minutes early. I want to thank you for your attention. Laura has your certificates. And let me say again, we have plenty of space next week. If you want to come back and learn more about the actual curriculum, which I didn't talk about at all, I have a strategy too. First, cover the science, then cover the curriculum. I have an Outer Planets talk, which is aimed at the general public, which I can give anytime anybody calls me and says, come give your Outer Planets talk.
Next week, is it in the same spot?
Yep.
Right here.
In this room.
Yep. We.
Same time, same channel, yep.
I think we're beginning to suffer from. We've been doing this for 12 years, and all the interested teachers have learned our spiel.
True, yeah.
Um,
And next week, you guys will be here again.
Yep. With more, there'll be more of us.
Okay.
It'll be more exciting. We'll do dance numbers. Thank you, Elena.
You're welcome. I won't be able to be here next week. I'll be in.
I think Karen is coming next week.
Okay, great. Okay. I've got a SIG meeting in Austin, so. That's what happens when they make you an offer. Not by choice.
Ah,
But I get a free trip, so
There
that's
you
not so
go.
bad. I get a free trip to Austin, so that's not so bad.
yeah, that's not so bad.
Okay, have a good weekend.
I will.
Okay, if you guys come next week,
Yeah.
just pay for it.
Okay.
You guys are both gonna pay for it again. So, and so if you want to pay next week, you can. If you want to pay now, you can. Whichever you would prefer. There, there's no one there. Okay. Kelly, right? Okay.
Thank you.
Next week, same spot, and there won't be a game happening, so. Yeah, actually, if anyone wants to take them all,
Actually,
whoever wants to take home sandwiches, please. Or if you guys want to take any muffins or fruit, I have the little to-go thingy here.
yeah, the graduate students have gotten an injunction. We're no longer allowed to throw this food at them.
Oh. So silly.
Thank you very much.
All right, see you guys next week. So you don't want to take any muffins, fruit?
No.
I have
I have 4 kids, not enough.
You have 4 kids. I'm gonna, if you want to carry it.
No, because I have to find my car. I have to remember how to get back.
What was it? Yeah, if you guys want to take anything. Where did you park? On the other side of the stadium?
No,
No.
I'm like, it was a big parking garage. Yeah, that's like
Oh.
Calhoun, is
Uh-huh.
that street? Yeah.
Oh, I know you're talking about the Welcome Center.
Yeah,
Oh,
that.
you did park far.
Yeah, close by the,
Did you park at the Welcome Center too?
By the hotel.
something about the art thing, you know, the hallway, the performance hall.
Yes, home
Yeah.
performance, yeah, that's over where you're at.
Yes. Yeah.
I will individually email you all a map of where Park Craft Suite, all that good stuff, so that you don't have to walk all the way across campus.
For an hour, I was lost.
Are you, this campus, I'm telling you,
My husband was.
You're not the first.
He said that, he said, Kelly, and I get lost all the time. He was like, Kelly, you are going to get lost. And I'm
Yeah.
like, I left
You're
20
welcome.
minutes early, thinking, you know,
Oh, you're
it
all
would
right.
take 20 minutes to get
Yeah, yeah. I was like, oh, Lord. That's why I was so late. See you next week. It was much easier for me having this right here, where I had access to my office, the project office, or copies, whatever. I don't know, how did you feel about the room? We can set it up different too.
We could easily accommodate, you know, we would,
We fit 58 middle school kids in this room.
yeah, why did we ever plan to use the cube?
I don't know, that's because who knows? I wasn't at that meeting last year.
Oh,
Okay, do you want to take these goodies home?
yeah,
Any of them?
but Barbara's trying very hard to see what's in it.
What? Well, what about the fruit? That's good for you. I mean, it's up to you. Whatever, you don't have to take it, I'll take it, but,
I'm sitting here thinking,
I mean, just good.
yeah, but I'm going to dinner at Ibiza.
Oh, so you're going somewhere from here, you're not gonna be to a fridge.
I'm not gonna be able to refrigerate
So
until about
refrigerate,
9
and then it'll
o'clock.
be all nasty and. I'll take the fruit, that's not an issue.
You know, I hate to say this, this has nothing to do with this. The problem here has nothing to do with the setup on my computer.
Oh, no, I don't think so. No, I don't know about that.
This is an intrinsic problem with the way that projector is interacting with this computer.
Oh, really?
Yep.
And you know what? I think you are very right on that because, like I said, we have several Teach Houston folks that teach in this room, and they're constantly having problems with what the image looks like on the screen.
It's
So,
a global setup problem that can't be addressed in 20 minutes.
so how would they
Regardless
address
of-
something like that? Like, what do they have to do? If I were to suggest anything to the director
It's a menu setting in there.
in the actual projector,
Yep.
would you have to get up on the thing to fiddle with it
Don't know.
or use the remote?
I don't know. Depends on what they've enabled.
Well, don't hurt yourself there. I can never read the print on those things, it's so tiny.
This puppy doesn't, oh, menu.
That would make a lot of sense. And I don't know that he did any of that when he was exploring earlier. They did, several of them commented how much they appreciated the color pictures that they got to leave with. Picture mode. Just natural. What happens if you go RDCs? No. So it looks a little different.
It was on this.
Okay, so it was on graphic. But it still didn't fix the
Yeah,
positioning.
right.
I'll talk with Tim and Daniel about it on Monday. Because they're the ones who are, you know, the director. Like that.
Laura?
Yes, sir. Did you figure it out? You figured it out! What was it?
Zoom.
Zoom! And so it was set on to Zoom. Awesome sauce. Now we know. We're going to educate them about it. So it's under position. Go back one more.
No,
How did you get here?
position.
Shift.
Okay, horizontal, we want to,
That's awesome. You know, we figured it out.
ooh, I may not have shrunk it quite enough.
You don't think?
Okay, so
Hi, can I help you?
Oh yeah, did you guys have the Mars Rover do something?
We had a workshop for teachers for Mars Rover, but the event is going to be January 31st,
Oh, okay.
2015. Look out for it. It'll be on the UH website. If you guys want to volunteer to be judges or anything, or
Okay.
whatever. You guys
Oh,
want to do it.
it's a competition.
It's a competition.
I remember that.
Yeah, we have 3rd through 8th graders that'll come, and this was an elementary competition and a middle school. So they'll come and bring their rovers and have a little theater presentation. It's like a big science fair. Basically. But we always need judges.
Awesome.
Yeah, if you Google Mars Rover UH, then you get all the event information.
Sounds
Yeah,
good.
here, let me give you one of these things. It's like a little flyer.
You're welcome. You too.
See, just recruited some more judges.
yeah, thank you. Okay. Well,
Don't
let's
be
see.
scared, but they're so big. That it's like moving around the room.
Stop screen sharing and stop broadcast.